Hey everyone, so you should know the drill by now. Have a piece of paper and a pencil in front of you, and then write the title of this lesson on the top of that page. The title is Quotient of Powers Property, and we're in section 10.1. Pause if you need to do so. So the first thing that I have for you is a little bit of a review of what we've done in 10.1 and 10.2. So pause the video, do these couple of problems, and then check your answers with me when you are done. And here are your answers. So for the first problem, we've got 1/2 to the 4th because our base is 1/2 and we're multiplying it 4 times. For number 2, we've got 2 to the 3rd and it says to evaluate it. So evaluate means that we're actually going to solve it and simplify it down to our lowest number possible without having to do any extra work. So 2 to the 3rd means 2 times 2 times 2, which gives us 8, and there's nothing else we can do with that 8. For numbers 3, 4, and 5, they all say simplify. And so simplify means that we're going to basically kind of do one step of it, and we're not going to finish solving it. So we're going to keep those exponents. Those exponents are okay in our answers. If you notice on this number 3, I have 2 bases and I have 2 exponents. So that means that I'm going to be adding my exponents. That's the rule. So I keep my base, which is x, and then I'm taking 4 plus 8, which gives me 12. Question number 4, the rule was if you have 1 base and 2 exponents, that means that you're going to be multiplying your exponents. So we keep our base, which is y, and then we're going to multiply 3 times 7, which gives me 21. The last one, I've got 2 numbers in my base, and I only have 1 exponent, which means that I'm going to distribute that 3 out to the 2 numbers in my base. So I've got 5 to the 3rd times 4 to the 3rd. If you missed a lot of these, make sure that you email me and let me know. Also, go back and rewatch the 10.2 because this is where we learned all of this. So today is specifically about finding quotients of power. So quotient, if you guys remember, means division. So these are all going to be division problems. There's going to be division in there. And so the first thing that we should do, because we don't know what the rule is yet, we have to expand these out. So I've got 2 to the 4th over 2 to the 2nd. Expanded out, I've got 2 to the 4th, or 2 times 2 times 2 times 2 over 2 to the 2nd, so 2 times 2. What I'm going to do that now is I'm going to cancel out the extra stuff. So I'm going to kind of play a matching game and match numbers in my numerator and denominator. So I've got a 2 in my numerator and a 2 in my denominator, matching those up and canceling them out. Because 2 divided by 2 gives me a 1. Anything times 1 is itself. So that goes away. Again, matching game, I've got a 2 up here, I've got a 2 down there, match them up and cancel them out. Now it looks like from my work that the denominator just kind of disappeared. That's not actually the case because we can multiply anything by 1 and it stays the same. So I'm going to add an extra times 1 right there. Now what I'm left with is 2 times 2 over my denominator of 1. I can simplify this by saying 2 to the 2nd over 1, or just 2 to the 2nd. And so 2 to the 2nd is going to be my final answer. Going on to number 2, again, we're going to do the same exact thing. So we're going to expand this out. So I've got -4 to the 5th. So that means that I'm going to write -4 5 times in my numerator. And then in my denominator, I've got -4 to the second. So I'm going to write out -4 2 times. Just like in problem 1, we're playing our matching game. I've got a -4 up top and a -4 at the bottom. So I'm going to cancel those out. And I get to do this twice because I have 2 -4s on the bottom, and then I actually have more than 2 -4s up top. Again, that's multiplied by 1 at the bottom, so it doesn't just go away. There's actually still something there. In my numerator, I know that I still have a couple of -4s, and I actually have 3 of those. So I've got -4 times -4 times -4 all over 1. That's going to simplify to -4 to the third power over 1, which simplifies to -4 to the third. I hope you guys are starting to see the rules. So what is happening? What's the pattern? Can we write a rule from this? The answer is yes. There's always going to be a rule for you guys. So when we're looking at this, whenever we see that division, we've got 4 divided by 2. And that was equal to 2. Next, we have 5 over 2, and that was equal to 3. So plug in some kind of an operation, so addition, subtraction, multiplication, and division, to be able to get 5 and 2 to come down to 3. And hopefully you see that pattern. So whenever we are working with a division problem, we are going to subtract the exponents. So we're subtracting those exponents. So if we didn't want to write out 7 times, because that's really time consuming, what we're going to do is we're looking at 7 to the 7 minus 3 power. So our base still stays 7 because that's our base over here. And then we're just taking 7 minus 3, which is going to give me 7 to the 4th power. And that's going to be my final answer there. Now it's your turn. Here's 3 problems to do on your own. Pause the video now and I'll give you your answers in a second. And here are your answers. So this is how I show my work with these problems. Rather than expanding it out, I write what I'm doing in my exponent because that's what's really changing. So for number 1, we have 8.5 to the third. Number 2, we have 10 to the third. And for number 3, we have -3 to the 8th. So now we're moving on to simplifying an expression. So again, we're going to expand it out if we need to. However, you can use all of those rules and operations that I taught you. So remember when we were talking about our new GEMDOS? GEMDOS means that we're dealing with grouping symbols. We're not just dealing with parentheses. And so a fraction is a grouping symbol. So we have to solve the numerator and we have to solve the denominator, and then we can work with our division. So for this problem, what we're going to do is we're going to simplify that numerator first. So I've got 3 to the 4th times 3 to the 2nd. I'm going to use my rule, which tells me that when I have 2 bases and 2 exponents, I'm going to be adding my exponents. And then I'm going to copy down my denominator just to keep it all the same. And I'm going to simplify that numerator now. So I've got 3 to the 4 plus 2th power. And so that's going to simplify to 3 to the 6th power. So now I've got 3 to the 6th power over 3 to the 3rd power. We just learned how to do this. We know that it's going to be subtraction. So I've got 3 to the 6 minus 3rd power. And then I'm going to actually do that subtraction and say 3 to the 3rd power. And so that's what that simplifies down to. Next, this one looks a little bit different, but I promise you it is basically the exact same thing. So there's a couple of ways to do this. Since this is lined up and it's kind of separating out those two fractions, what I'm going to do first is I'm going to simplify those fractions. And so this first fraction, I'm looking at A. Since it's division, I'm going to do subtraction with my exponents. So A to the 10 minus 6, and we're going to copy down this multiplication symbol right here. And then we're going to do, it's still an A, and then 7 minus 4 for my exponent. So 7 minus 4. Now we're going to simplify it, actually do that subtraction. So A to the 4th power times A to the 3rd power. We still have two bases two bases that are the exact same thing. And so that means that we can simplify it a little bit further. So this is where we add our bases because we have two of the same bases and two exponents. So I know that my similar base is A, and then I'm going to add those two. So 4 plus 3 is going to give me A to the 7th. And that is my final answer with that one. And now it's your turn. Try these two problems on your own, and I'll give you your answer in a second. And here are your answers. So for this first one, we're multiplying on the bottom. That multiplication is going to be addition because we've got two bases that are the exact same number, and we have two exponents. So 3 plus 5 gives me an 8, and then we're subtracting those two, which gives me 7. So it's 2 to the 7th power. In the bottom question, we are doing this subtraction or division first. So we are taking 9 minus 4, which gives us our 5 as an exponent. And then we're doing 5 minus 2, which gives us our 3 as an exponent. We know that we're going to be adding those two exponents because two of the same base and two separate exponents. So 5 plus 3 gives me an 8. So my final answer is 5 to the 8th. Here's two more problems for you to do. Pause the video and check with me after. And here are your answers. So these ones were a little bit different because we had two different bases. But it's just like before, we handle one base at a time. So I expanded these ones out so you can see the thought process a little bit better. So for this first one, we've got 6 times W, or 6 to the 2nd times W. And then in the denominator, we have 6 times 6. We're canceling out all of our matching numbers. So we actually got rid of all the 6's, and we're left with just a W over 1, which equals W. This one looks harder, but it's the exact same thing. So this is the expanded out version. I don't have anything to match my A's up to, so that actually stayed A to the 3rd. The B's, I had 4 B's up top, 2 B's at the bottom. 4 minus 2 gives me a 2, so I've got B to the 2nd left over. And then my last thing, I've got 5 to the fourth in the numerator and 5 technically to the first in the denominator. So I'm looking at 4 minus 1, which gives me a 3. So we've got 5 to the third. So my final answer is a to the third times b to the second times 5 to the third. If you want to add it over 1, I'm totally okay with that. If you leave out the 1, kind of like how I did up here, that is an acceptable answer as well. And here's your homework. We have a Zoom today, so if you have any questions at all, please ask me during the Zoom or ask me through email.